Alright class, in this lesson we're going to take a look at the differences between the common log and the natural log. The common log is one that you would see on your calculator if you saw the log button. It's looking at something that's base 10, okay, and you don't always have to write base 10, it's just assume that it's there. For example, if you had log base 10 of x, you could just write log of x. Or if I had like log of 20, it really means log base 10 of 20. We just don't have to write it, okay? And so you go back and forth, it really doesn't matter if it's there. But it is the one that you see on your calculator. Okay, so speaking of calculators, we've got logs, glade, and calculators. It's a conspiracy, or nature on mathematics, sorry, it's a bad joke about logarithms, and we're plugging them into the calculator, and the Glade commercial, of course, is plug it in, plug it in. So we are going to take logs and just plug them straight into our calculator. So now there's two types of calculators. There's the calculator that is found on the iPhone or iPad, and these are what I call the junky or just terrible calculators. The reason why is because you actually need to push 378 first. So right here it needs to say 378, and then you push the log button. So then you come over here and you push the log button. Okay? When you push the log button, so you should end up with 2.577. Okay? Now, and then 49, but so 5, I guess. And what we want to hopefully have is a better calculator than the iPhone or iPad calculator. Most calculators, like a TI 84, like a graphing calculator or any other just regular Texas scientific calculator, most of them you can actually just punch in log, like push the log button, and then push 378, and it should give you that answer. So a little less work and a little bit more straightforward, instead of being backwards like the calculators you find on your phone. So same thing for this second problem. You just, if I was to do it on the iPad calculator again, I would just go ahead and put in my 3,780, and then I would push my log button. Okay? Or, again, like I said, if you have a regular scientific calculator, you just punch it straight in the way that it's written, and then you should get 3.5775. Okay? So you can see that in these two different, notice if there was a zero here, look at the difference between this log and this log down here. The decimal portion was the same, it was just a whole number bigger, and that's because there was a zero there. But anyway, just plug it in a calculator and it should give you the straightforward answers for these problems. Then we get a little bit harder when they actually ask you to find for x. Now, I've said in previous lessons that if you have a log where you have x, what we need to do is actually don't solve it as a logarithm. You want to solve it as an exponential, so we need to go exponential. And the way we go exponential is we have to re-put the 10, the base 10 there, because it is a base 10 if nothing's written, and go exponential, which means you write 10 to the 2.8802 power equals x. So we've actually solved it, but then we should go ahead and put it in our calculator and work it out. And if you do that, and you raise 10 to that power, you should get 758.93 if you round. Okay, well there's actually a button on our calculator. If you push this second button right here, whoops, sorry, 1 second. The second button right here, this log button will actually turn into a 10 to the x power. And actually that isn't the way that it works on the iPad calculator, but on most scientific calculators there's a 10 to the x right above the log, so when you push second it's really doing 10 to the x, so that means you only have to put in the 2.8802. Another way to do it, if you're plugging in a calculator, is you push 10, and then there's often a little up arrow, like this little caret. There's not one on this particular screen here, but on my TI-30 scientific calculator, what you'll see is that there's this second button, of course, and then the log button is right below it, and you can see right here inside what I circled, you can see that little 10 to x. So when you push the second button, it actually raises it, and that makes us what we want. So basically it's doing, so you push second, log, and that really on your screen should display 10 to the x power, and then you just put your 2.8802. Okay, and then that gives you the 758.92 that I had earlier. Okay. Now the same thing goes for the second problem. Basically it's log base 10, so it's just 10 to the fourth power equals x. So it's just 10 to the fourth equals x. So you can just figure out what 10 to the fourth is, and the easy thing with the 10, if you're raising it to any power, you just add that many zeros and behind the 1, and so you should have 1, 2, 3, 4 zeros, and 10,000 should be your answer. And again, if you wanted to do it on a calculator, you would just push the second button right here, and then push the log button, and then just type in 4, and you would go ahead and it would give you the 10,000 right here. Okay? Now we're going to go ahead and take a look at natural logs, as if there's a different kind. They're all natural, right? All logs? Well, not exactly. We just had common logs. And the difference between a common log and a natural logarithm is that natural logs have a base of e. Again, common had a base of 10, so it was log base 10. Well, here the only difference is it's base e. Whenever it's base e, like this, we just write it as ln, like log natural. I don't know, it's a French log. So we write ln of x whenever we see a base of e. Okay? So it has all the same log properties that we had. We had the multiplication property, the division property, and exponent property that we had with our regular logs, but notice it's just written ln, because it's still a regular log. It's just base e. So these are all, when it says ln, it's just log natural. I mean, it's base e, but it's just a regular log, base e. All the compression and expansion rules still hold true. So if I was to work on simplifying some things with base e, first of all, anything to the 0 power is 1. It doesn't matter if it's e, but e is actually a number. It's kind of like pi. You know how pi is equal to 3.14? Well, it's not equal to 3.14, but e, if you want to figure out what e is, you actually can just take your calculator, and if you have this TI-30, you can just look right here, right above ln, you'll see there's an e to the x button. So if you push second ln, you should get this e to the power, okay? And that's what we're doing here. We really just want it to the first power. So if you push 1, it would give you what e actually is. And it is 2.718, and then it kind of rounds to 3. But it's an irrational number, so it goes on forever. But that's what e is, okay? So it's, instead of having log base 10, it's really log base 2.7183, and then it keeps going forever. But that's what these logs are now. So now we're saying, all right, well, let's find the ln of e. Well, what we're going to do here is we're going to use the rule that if it's ln, it must be a base of e, and we're taking of e. Well, the rule was that if we had the base, we're really asking the question, what power can you raise to e to? So e to what power will give you this e right here? Well, there's nothing written up here, so there's a 1. So that must mean that the answer is 1. So whenever you have ln of e, the answer is just 1. Okay? So if we take a look at the second problem, we're asking ln of 1. So it's really asking, what do you raise? So if it's ln of 1, it's ln, the base is e of 1. What do you raise e to? E to what power gives you 1? Well, we just talked about that up here. Anything to the 0 power would give you 1. So that must mean that this was a 0. So x is equal to 0. Another way I could write it is that 1 is really equal to e to the 0 power. So if these both have the same base, then x must be 0. Okay, so that's the answer here for ln of 1. Now let's take a look at ln of e to the third power. And again, really it's ln base e of e to the third. So again, the question is e on the base, e to what power is equal to e to the third? Well, that would be the 3. So the answer for this one is 3. And finally, this last one, really it's ln base e of e to the t power. So we're really asking ourselves, e to what power is equal to e to the t power? Well, that must mean that the answer is t, because we're taking e and raising it to the t power to get t. I know it's kind of weird because it's variable, but that's what it is. Now finally, we're going to take a look at what it looks like to plug in natural logs into the calculator. So to plug in a natural log in the calculator, all you have to do is use your ln button. So if you have this particular TI calculator, all you have to do is straightforward push this button and then push 378, and on your screen it will say ln 378. Push enter and you should get 5.93, and then it should round to 5. So 5.935. Okay, and the same thing for the second one. You just go ahead and type that in, push your ln button, and then you get ln, and then type in your 3,780, and that should give you 8.237, and if you could round to 5. Now again, if you have the iPad or iPhone calculator, the only difference is that you'll type in this 3,780 first, and then push the ln button, which on this particular calculator is right there. Okay, so it just does it backwards from the way that it looks. Alright.